Okay, this is notes 1.7, selecting procedures for limits. So remember in the last notes, we had to manipulate the limit either by factoring or using the special trig properties in order for us to not just end up with an indeterminate, 0 over 0. So for this one, we're going to learn how to manipulate this by rationalizing the fraction, so multiplying by the conjugate, and then also simplifying complex fractions. Okay, so first let's check this one. Again, we always check by direct substitution first. So this means we have the square root of 5 plus 4 minus 3 over 5 minus 5. This is going to be 0 over 0, which is indeterminate. So I'm going to take the limit as x approaches 5, square root of x plus 4 minus 3 over x minus 5. And I'm going to multiply the top and the bottom by the conjugate. So if you recall, the conjugate is a way to get rid of the radical. So notice the conjugate is just the opposite sign here. Okay, so since this is minus 3, my conjugate is plus 3. If there is no add or subtraction outside of the radical, then you just multiply by the radical itself. Okay, so now I'm going to multiply across, and I get the limit as x approaches 5 of x plus 4 minus 9. Okay, radical times a radical, the radical will be squared, so it cancels out, so x plus 4. Radical times a positive 3 is positive, negative 3 times the radical is negative, so it cancels, and negative 3 times 3 is negative 9. And then I'm just going to rewrite the bottom part. And so if I simplify this, I get x minus 5 over x minus 5 times radical x plus 4 plus 3, which means the x plus 5's cancel out, and I'm left with the limit as x approaches 5 of 1 over the square root of x plus 4 plus 3, which means now I can do direct substitution, and I have the square root of 5 plus 4 plus 3, which is 1 over the square root of 9, which is 3. 3 plus 3 is 6. So 1/6 is my answer. Okay, try this again. But notice this time on number 2, my radical's on the bottom. So I'm still going to do the same exact thing. I'm going to multiply both by the conjugate. Of course, this is me already checking that I'm going to get 0 over 0 first, and then I'm moving on. So the limit as x approaches 10 of x minus 10 times the conjugate of 3 plus the square root of x minus 1. Notice it went from subtracting the radical to adding the radical. Over 9 minus x minus 1. Okay, remember, if I'm multiplying by the radical, when I FOIL, the middle terms will go away, and I am left with the first term squared, so this squared, and the second term squared. Okay, and that's what I end up down here. Okay, I want to end up canceling the x minus 10, so I need to simplify this. So I have x minus 10 times 3 plus the square root of x minus 1 all over. Well, if I simplify this, this is going to be, see, that's minus x, 10, so 10 minus x, or I can say negative x minus 10, which means these would cancel. And I have the limit as x approaches 10 of 3 plus the square root of x minus 1 over negative 1. Substitute the 10 in, and I get the square root of 10 minus 1. That's a square root of 9. That's 3. 3 plus 3 is 6. 6 divided by negative 1, negative 6. Okay, so that's rationalizing the fraction by multiplying by the conjugate. Now we are going to manipulate the problem using complex fractions. Okay, so first we always plug it in and we double check that this is 0 over 0. Okay, since it is 0 over 0, I need to look where my complex fraction is, and that's right here. It's on the bottom. So notice I have two fractions that do not have a common denominator, so my goal is to make them have a common denominator. Okay, so since one is x minus 4 and the other is 4, the simplest way is just to multiply them together to get a common denominator of this, 4 times x minus 4. The first fraction here is missing a 4. So in order to do that, I would multiply 4 times 1, which is 4. The second fraction here is missing the x minus 4. So I do x minus 4 times the 1, and I get x minus 4. Okay, this combines to be x over 4 times x minus 4. So I have the limit as x approaches 0 of x. I'm going to change the x into a fraction by writing it over 1, dividing it by x over 4 times x minus 4. So now I have a fraction divided by a fraction, which means this is the same as saying the limit as x approaches 0 of x over 1 times the reciprocal, 4 times x minus 4 over x. And when I take the reciprocal, the x's cancel out. And I can now do direct substitution. So 4 times 0 minus 4, and that gives me negative 16. Okay. Last example here. I notice that when I plug in 0, I get 0 over 0, so I have to keep on going. I see that I have a complex fraction in the numerator, so I'm going to first get a common denominator, and that is going to be me simply multiplying them together. So 9 times x plus 3 squared. The first fraction is missing a 9, so 1 times 9 is 9. The second fraction is missing the x plus 3 squared, so I write that down. Okay. Simplifying this, I need to first simplify x plus 3 squared. Well, that is x squared plus 6x plus 9. And since I'm subtracting this subtraction sign is going to go to every single term here. So I have 9 minus x squared minus 6x minus 9 over 9 times x plus 3 squared. Okay, the 9's cancel out. Okay, and I can take out, let's see, should I leave it? Should I take it out? We will go ahead and take it out for now. Okay, I'm going to simplify further. So I can take out a negative x, and I'm left with x plus 6 over 9 times x plus 3 squared. Okay. Remember, that is my numerator, so I'm going to plug that back in. So I have the limit as x approaches 0 of negative x times x plus 6 over 9 times x plus 3 squared over x, turn it into a fraction, so over 1. That's the same as saying the limit as x approaches 0 of negative x times x plus 6 over 9 times x plus 3 squared times the reciprocal, so 1 over x. The x's cancel, and I have the limit as x approaches 0 of x plus 6 over 9 times x plus 3 squared. Now using direct substitution, that leaves me with 0 plus 6 over 9 times 0 plus 3 squared, which is 6 over 9 times 9, so 6 over 81, which reduces to, I forgot a negative. So it's negative, which reduces to negative 2 over 27, because that are both divisible by 3.